This is Jeremy Apthorpe. He's a developer on Chrome at Google, and he works on Chrome apps. And he's going to be talking to you about the future of HTML5 applications.
Hi, everybody. Thank you. So, as Shane said, I'm a software engineer at Google. I have been for about a year and a half working on Chrome, and particularly on Chrome apps, which I'm going to be talking about today. So, a little bit about me. I don't need to say that anymore. It's already been said. Let me fix the size of this, actually, so you can see everything that's on the screen. Great. I work for Google, but this talk does not contain Google's opinions. It contains my opinions. So if I say anything bad, it's not Google's fault. All right. So let me tell you the story of anybody who's ever wanted to make an app. It goes like this. I just want to make an app. That's the easy bit. That runs everywhere. That's the hard bit. And this was sort of what Java promised us in the 90s. You know, write once, debug everywhere. The dream of the 90s. But Java has more than just its cross-platform problems. It produces apps that look like this. And, well, yeah. So what options do I have as someone who wants to make an app to build something that looks good, that works everywhere, and that's easy to develop? Well, I could write a native app, but write one for Windows, one for Linux, write one for Mac OS, and then I got to write one for iOS, got to write one for Android, and suddenly I'm spending all my time doing just porting the same app from platform to platform, and get no time to spend on the interesting part of app development, the fun part of app development, which is writing your app. So I want to use the web because, well, the web browser already works everywhere, so I don't have to do that work. But if I use the web, my app is stuck in a tab, can't break out of the browser. Tabs are kind of ephemeral. They close and open. They're hidden behind other things. They don't show up in Alt-Tab or on the taskbar. They don't integrate with your operating system very well. They kind of live in this world that's sort of subordinate to the browser. So they're stuck in a tab. They only work online, barring app cache, which kind of doesn't work. And anyway, no users realize that they can type in a web URL while they're offline, and it'll work sometimes, don't really know. And the web apps are untrusted. You don't get any access to any of the things that you have as a native app developer, like any sort of dangerous APIs, like writing to the file system, or accessing USB ports, or Bluetooth, or accessing sensitive system information, like contacts or media galleries. So web apps are kind of stuck in this sandbox, and that kind of limits what you can do with a web app. So as web developers, we want to have our cake and eat it too. We want the ease of development and the speed of development of the web, and of flexibility and the ability to build really beautiful apps really easily. But we want the power and the integration that we get from native apps. So what can we do about this? Well, actually, funnily enough, IE5 actually had this capability. There was a thing called HTAs, HTML applications, where you could bundle up some HTML and JavaScript into a zip file, put a .hta extension on the end, and double-click it, and it would come up with a window, and it would have your app inside it. No browser Chrome, no URL bar. This is basically what we're building in Chrome today, and IE5 had it in 1999. But for various reasons it didn't work, one of which I suspect is, well, as you just heard, it wasn't extremely fun to write HTML for IE5. So this isn't really supported anymore by Microsoft and kind of died. Fast forward a little bit to about 2006, I believe, and there was a product by Mozilla called Prism, which let you build a little app package, and you give it a URL, and when you double-click on that app, it would open up and it would just show you that URL. Like just that web page with no URL bar or anything. It was great for like opening Gmail, but unfortunately, if you say clicked a link, it would just navigate inside that window, and it still only worked online. So it kind of solved the stuck in a tab bit without solving any of the other issues. It didn't let you access any untrusted, dangerous APIs, and it didn't let you run offline, which are two of the kind of most key parts of this. And then 2007 came Adobe Air, which does actually solve all of these problems. It runs outside the browser, it runs offline, and you can access parts of the system that you can't on the web. And it embeds WebKit and lets you build apps that of the kind that we want to build as web developers, web tech, native tech. But yeah, every Flash page ever looks like this. So, and Adobe Air, a lot of APIs were kind of clunky to use, and it's actually enjoyed quite a lot of popularity. I did some Google Trends searches. It's still hugely popular, but not really growing, and a lot of it's targeting, a lot of the Flash development tools now are targeting HTML5, so it's sort of kind of staying steady at the moment. When all of this started to take off was around 2010, when people like this suddenly became viable. I'm not entirely sure why it was 2010, but I have two hypotheses, and one of them is that this is when HTML5 started to get really good. I'm sure it correlates with the release of IE9, but for those of you who are here for the last talk, but this is when HTML5 started to get fast, when JavaScript started to get really fast, and we started to get a whole bunch of new tech in HTML5 that made it really attractive for building apps in. And my other hypothesis is, as you can see, mapped on this graph, I don't know if you can read this, the red line here, that's searches for Node.js. I think Node.js as well had a huge impact here in convincing developers that JavaScript is actually a real language that you can write real apps in. So I think those two things had a big impact on what came next, which was that people started to build sort of shell applications that embedded the browser. So you build a little shell app and shim code to talk to the native app, so the web developer can write JavaScript and HTML and show it up in a native style window. And there are lots of frameworks that let you do this: Accelerated Titanium, Senchar, App.js just came out recently. But this has been a much more popular technique on mobile with things like PhoneGap, which is now called Cordova, I believe, which lets app developers on mobile build one app that'll run on Android and iOS, which cuts their development time basically in half. So this is hugely popular on
just a correction.
On phone.
Build.
Sorry?
PhoneGap Build. That's my name.
Oh, okay, sure. PhoneGap Build is their new name, and HTML on mobile is increasingly becoming a popular target. And Firefox OS, which I don't actually know that much about, but it's going to be all HTML, which is awesome. And there's also Chrome OS, which is the only thing that runs on Chrome OS is HTML. And the other big surprise to me, at least, was that one of the major ways to build applications on Windows 8 is JavaScript and HTML. How cool is that? So this is really something that people want to do, and it's really something that is economical, it's fun, and it builds great apps. Like, people build incredibly good-looking and really usable apps in HTML5, and there's a lot of expertise as well. So the web has been sort of this equalizer, and bringing a platform to app developers that lets them write once, run everywhere. Like we were. So that's sort of where things are at. So recently, with all this activity going on in this space and lots of different companies building their own platforms, we do, and I was hoping that I would be the first one to come up with this, but this is what happens. Anyways, so we're building a new standard, and there's the SysApps working group, which is a W3C working group chaired by Adam Barth at Google and Wong-Suk Lee at Samsung, which is trying to make an attempt to bring all of the work that all of these people are doing and standardize it so that I, as an application developer, can build one application package and sort of have it run on Mozilla and on Tizen, which is Samsung and Intel's operating system, have it run on Firefox OS, have it run on Chrome OS, have it run on the desktop. I can just build one application and have it run everywhere. Please. So the working group actually has members from a huge number of companies. Some of the more surprising ones are, there's a member from Zinger, Mood Lighting, and a lot of telecom companies as well, actually, who are interested in this and helping out on the standards group. So they're aiming to have a first published working draft in Q4 of 2012, which you may notice is in the past. So there's still a lot of issues to be ironed out, and I think one of these is that everybody kind of has their own thing and really wants the standard to just be what they built, so that they don't have to do any work, including us at Google, guilty. But it is moving forward, and we do have a number of draft specifications for the execution model, which is just how do I package up all of my stuff and send it to the browser, and how is, like, what's the process lifetime? How do I launch an app? So we're actually getting pretty close to having a spec for that. So in lieu of an actual spec to talk about, I'm going to talk about what we're doing in Chrome and how it works in Chrome today, and probably for the foreseeable future, although we do have a big investment in the spec, and we do want to make sure that we're spec compliant when there is a spec. So I'm going to talk about three things. I'm going to talk about the execution model. So how does it look in terms of what are my windows doing, and how do I receive events from the browser? I'm talking about what we're doing to make sure that these apps are secure. And we're hoping that we can do better than native in terms of the security that we can offer the user. And I want to talk about some of the dangerous APIs that we're exposing to the developer. So the execution model. For a start, in Chrome at least, the way this is going to work is that all of your resources are going to be packaged into a CRX file, which is basically just a zip file with a JSON file in it called manifest.json, which tells you some things about the app. And then inside that, there's a whole bunch of HTML, JavaScript, images, all the resources that you need for your app to run. And the reason we're putting it in a package is because we want, one of the most important things about this whole endeavor is that apps run offline. Even though we're kind of online most of the time, it's always a sucky experience. There's more than one use case for offline, and one of them is you're not quite offline. You have a kind of dodgy internet connection, which some of you may be experiencing right now, but you still want to be able to open that email. So it's super important, and you'll see a lot of that as I go through the rest of the features of this technology. So CRX, or some other equivalent packaged thing with all of the resources that are needed to run your app. In that manifest.json, you specify what's called a background page. So a HTML or just a JavaScript, and we'll generate the HTML for you, of a page that gets loaded in the background. Doesn't get into the user, doesn't have any user interface in it. It's just there to run your script, and it has a document, and it runs your script. And what you do in your script is you add listeners to various different events. So I've written an example here for what an on-launch handler might look like. But one of the features of this background page is that it's not there all the time. When your app's not running, we close it down. It's not, so we're calling it event pages in Chrome. First, your app, we load up your background page, we run the scripts, and we look at what events you register for. And then we close down your page. We say, go away, and we save memory. So when we get an event in, like when the user clicks on the icon for your app, we load your page back up and we send it this event saying, hey, the user wanted to launch you. Other events that you might want to register for are things like, I received a push message. So maybe the Gmail server is saying, hey, you've got a new email. And then I can update some UI surface or show a notification or something like that. There's an on restarted event that we've implemented for if the browser crashes and restarts and you want to be able to load back up your state from local storage or something. And there's a few other events, but the key thing is that while your app isn't running, Chrome is free to just sort of kill this at any time. We do keep it around while your app is running, so you can keep state in there while your app is running and use it as a sort of controller if you have many different windows. But we sort of lazily close it once there are no more sort of pins keeping it alive. So pins are things like if there's a window open on your app, we'll keep your app alive. If you've got a socket open from the background page and you're listening on it, we won't kill your app. So there are various things to do to make sure this stays alive, but basically when it's not needed, it goes away. And in general, we're hoping that apps are written with the idea that they could be killed anytime, and so that they should be constantly saving. So the background page controls any windows that you show, which are a separate DOM entirely. So it's kind of like window.open. You create a new window and then you can script it directly. They're all in the same process, so you don't need any sort of message, asynchronous things going on. You can just sort of grab out the child window and fiddle its internals directly. So this is kind of how it looks to create a new window. So you specify like a width and height, and you get a callback when it's done creating the window, and you can access directly the internals of that window. So they all run in the same process, sort of all in the same thread. Oh, and yes, whenever anything in your user interface changes, you should save it, because we might terminate your app with extreme prejudice. Okay, so that's sort of how the execution model looks. That's how your app looks in terms of where all the data is. There's a background page which receives events, and there are event pages which are their own windows. Sorry, did I say event pages? There are windows which are their own DOM and separate from your background page. So I want to talk about security. With great power comes great responsibility. We want to make extra sure that the apps that you write on this platform, because we're giving them extra powers, access to extra APIs, things that we wouldn't expose to the drive-by web, that we wouldn't want the browser to do just if you're visiting a website. So we're taking extra care to ensure that because of this higher trust domain. And we want to also, while we're at it, ensure a few things about sort of properties of your app. We want to make sure that apps are uninstallable. We want to make sure that if a user installs your app and then uninstalls your app, all the things that came with your app are gone. It kind of, Windows sort of has this problem of when you install an app and uninstall an app, there are still sort of bits left around, you don't really know where they are, and we want to make sure that we don't have that problem. We want to make sure that apps are independent, so that if you install one app and then install another app, and then remove the first app, the second app's not going to stop working, or any sort of combination like that. We want to make sure that apps don't have interlinks, like that apps aren't interlinked, so that they can be removed and installed separately, and they won't break. And I kind of already made this point, but we want them to be secure, especially secure. So we're kind of borrowing a few things from iPhone or like from the iOS. This started to become popular once iOS came out. Apps on iOS feel safe. You can install an app and know that it's not going to litter your system, and know that if you uninstall it, it's going to be fine. So we want to make sure, we want to borrow like the good parts of this. The first part to security is that there's sort of this trust gesture that isn't present on the drive-by web, which is installing. These apps don't just sort of appear on your system. The user has to click a button that says like install this app before the app can run. And in that like, do you want to install this app dialog, we have a list of upfront permissions. Now, a lot of Android apps sort of have this like huge long list of permissions that seem totally irrelevant, and everybody just clicks OK, even though it says like I want to access your contacts and the network and your position, your location, and all of your SMSs and who's calling, and it's like a flashlight app, and you're like, but everybody's learned to just ignore this list because it's meaningless. A lot of the reasons that apps have those extra permissions that they seem to need is for ads. So anyways, we want to do slightly better than that, and not just have a list of permissions, but actually look at those permissions and decide based on those permissions whether there's sort of a threat here. So for example, if the app wants to access raw network sockets, that's probably fine. If it wants to access separate, like if a different app wants to access just your contacts, that's probably fine. But if a single app wants to access both your contacts and raw TCP access, that might be cause for alarm, and we might pop up a thing for the user or pay extra attention to it in the store. Those things, so we can do slightly better than just a flat list of like, here's what this app wants to do. But the important thing about permissions is that they provide a bit of a sandbox, a bit of a sort of a way for us to control, to do a number of things really, to control what your app can do, to let app developers tell us what their app does in a sort of programmatic way. And to make sure that if your app accidentally does something which you didn't intend to, it can't cause a security issue. So for example, if we didn't have this permission system, if we just gave every app all the permissions, your app could accidentally somehow write to the file system if it didn't ask for that permission. So if we codify all the ways that your app can interact with the system in this list of permissions in the manifest file, it sort of shields you against mistakes as well. So another part to the security of these kinds of apps is that they're isolated from other apps from the browser and from the browser as well. So anytime you perform like an XHR request or anything from inside one of these apps, it doesn't get cookies from the browser. It doesn't get cookies from any other app. So it's sort of in its own context. And there's a few ways. This is kind of sad because you don't want every app that you log in with Facebook to have to ask you to type in your password again. So we're actually providing an identity API to deal with some of the fallout from this decision. But it's good because it means apps can't sort of infect each other in a way. And this is part of making sure that apps are independent. Another part of our security is that we removed eval and new function, and a lot of other ways of evaluating scripts that you download from the web, like dynamically executing code. We try to make sure that you don't do that. So you can't document.write a script tag. You can't create a script tag, set it in an HTML, and inject it into the document. One of the ways that we do that, if you were here earlier today for the talk about CSP, is that we have this stands for Content Security Policy. We have an enforced CSP policy that that means you can't have any inline scripts. You can't have scripts from other domains. And generally just prevents against a whole bunch of cross-site scripting attacks that you might otherwise sort of accidentally expose yourself to. And also, this is sort of off on a tangent, but no foreign image tags either, or iframes. The reason no foreign image tags is offline support, actually. The image tag in every web browser has basically no capability to work when the internet connection is kind of dodgy or might drop out halfway through loading an image. You just get a broken image sign, which is kind of a sucky experience. But the video and audio tags have reasonable offline capability. They show a little thing saying, like, couldn't fetch the video, and they have a button that you can click to, like, try loading it again. So video and audio tags are fine. Anyways, back to security. So one way to get around, like, because a lot of APIs actually need eval and new function and this sort of thing to work. Particularly templating libraries use this a lot. And one way around that is to use what we call a sandboxed iframe, which is an iframe that goes in your app that doesn't have access to any of the APIs that your main pages do. So it can't call file system write, it can't call any of the USB APIs or anything like that. But you can post message to it, and you can set the initial content of it from the parent page. So you can build your templating or whatever you need to do eval inside the sandboxed iframe and have it just send messages out. And that way you can sort of have a little bit of security interface between your untrusted code and the code that you know is pretty secure. And there's one other technique for this, which is WebView. And this is basically like, this is almost like having a little Chrome plugin that you put inside Chrome. It runs out of process, so it runs in a completely different process. So even if the WebView contains, like, if Chrome has a bug and the WebView contains like the page that you load inside it contains some exploit of that bug, it can only go so far as the other render process. It can't access any of the privileged APIs that your app has access to. And this is the way to load arbitrary content from the web. It's basically like putting a UI web view or a Android browser web view inside your app. HTML within an HTML. So that's what we're doing to try and make sure that these apps are secure and to try and mitigate the fact that we're providing a whole bunch of dangerous APIs. Which, speaking of, I realize I'm going extremely fast, I think. Anyways, 20 minutes. There's definitely going to be a lot of time for questions. So some of the APIs that we're building are actually really cool. My favorite one is actually not the raw USB API, which lets you basically write device drivers for USB devices in JavaScript, which is totally cool. Not the Bluetooth API, which lets you do the same for Bluetooth devices, which is really cool. There's people who wrote things to access the Fitbit, which is like a little device that you wear on your belt or something, and it tells you like how many steps you've taken that day and what your heart rate is and all this sort of cool data. So it can interact with that just by an HTML and JavaScript app. But actually, my favorite is the Serial API. So the MakerBot actually is a 3D printer that you can buy for about $1.50, and it talks serial. And basically anything that uses Arduino talks serial. So this API actually, and I built like the first little part of something to actually drive the MakerBot just using HTML and JavaScript. So I got to have like an on key and send this serial command, and then I can use the arrow keys to control like this machine over here that's doing 3D printing. So that was totally cool. And a lot of guys at the Mountain View office at Google have been sort of playing around with this stuff. It's a lot of fun. One of the other APIs that's really cool is raw sockets API. So you can open up a TCP or a UDP socket to anywhere on the web on any port, and basically sort of send whatever you like down it. So you can finally actually write an IRC client that works in JavaScript and HTML, or a mail client, or somebody wrote a BitTorrent client, which is something that's kind of impossible to do with the APIs that you get regularly in the browser. A couple of the other APIs that we provide, Media Gallery API, so we provide an API that you can call and it will return you like all of the photos that are on the user's computer, and there's a little bit of UI that the user can sort of select where to draw those photos from. I think on Chrome OS it just takes them from Google Drive. There's also a file system write access, but it's a little bit restricted in that you can only write to a file that the user has selected in a file open dialog box, which kind of gimps a whole bunch of really interesting applications. Like you can't really write code editors in this because you don't want to have to open up in a file choose dialog every single source file in your entire repository. That's kind of not a very good experience.
Can you just make a directory?
There's possibly, we're trying to get that. The question was for the recording, can you designate a directory and recursively get all of the contents of that directory? Not yet, but soon, I hope. And the identity API, which I talked about earlier, which lets you get, and it sort of does the OAuth dance for you, and you can give it a URL and it will do OAuth and return you the cookie. And it'll do that with the cookies that are in Chrome itself. So if you've logged into Facebook in Chrome proper and you want to get the user's identity on Facebook from within your app, you can call an API and it will do the OAuth dance with Chrome's cookies, which means you probably don't even need to show a dialog to the user. They can there'll be a dialog that Chrome shows saying, do you want to log in with this? You click it. Say yes, I want to allow this app to use my Facebook thing, and it just logs you in straight away. You don't have to type your password again. So that's the sum of it. You can play with this today if you go to this URL, developer.chrome.com/apps. Questions?
Are you able to write apps that access USB and Bluetooth on an iOS device using HTML5?
Unfortunately not. We're still in the early stages of what we're doing in iOS, and we definitely want to do as much as we can, but I believe that those APIs are actually restricted on iOS and that no app, even if it's native, can get unlimited access to USB and Bluetooth. You can only access it through a limited set of APIs that iOS provides. So we're probably going to be restricted there, but on Android we'll do as best we can to offer those APIs.
So previous slide, just to run.
Sure.
Oh, that's a direct. Is this coming soon to Chrome on Android? Since
I can't talk about timelines, but yes.
Because I know it's obviously.
It says early 2013 on the site, so.
Oh, good. Well, it'll be on early 2013. Yeah, soon.
So for games, it makes sense for every game to have its own UI. If you're doing like a word processor or some more advanced app, you want it to look like a native app on that application and, you know, interact with the same shortcuts that every other app on that platform uses. How are you solving those type of problems at all?
So for word process particularly, WebKit and Chrome have already done an awful lot of this work for like text areas and stuff. If you want something more advanced than that, you can sort of wait for content editable to be usable. But really, beyond what's already in browsers to build native looking and native behavior UIs, we're not doing a whole lot more. One of the things that I've noticed while sort of researching this sort of thing is that there are an awful lot of apps that actually don't look or behave natively at all that we use, or that don't look native but feel native. And it's sort of a different thing to just the the way that the buttons look. It's about fonts and spacing and how it responds to certain shortcuts. So we're doing as much as we can to make apps feel native, but not necessarily look native, because we don't want to go down the Java path of like, these things really are different on every different platform, and that's kind of got to be the app developer's responsibility at some level. Does that sort of... No, and yes.
Just a question about PhoneGap, Cordova, whatever you want to call it. It's got
PhoneGap build, I think it was.
got quite a comprehensive API set for handling phone requirements, accelerometers, things like that. Are there plans in the pipeline to...
So some phone-specific things are already in the web platform generally, so you can already access accelerometer data just on any web page that you can just get it out of the DOM. There are some other APIs though that are more that are phone-specific that are being pursued by the standards groups. Those, like specifically the ones that are on their schedule for Q2 2013. Are telephony APIs to make calls and to receive events. Like when a call comes in, they want to be able to handle those events. Messaging APIs, contacts APIs, calendaring APIs. So all of these things that are going to be really useful for things like Firefox OS and Tizen are being hashed out in standards groups. So Chrome specifically, because we don't have a phone that runs Chrome OS, doesn't have those APIs yet, but there's definitely a lot of interest in them.
With the no foreign resources, how will you handle things where people might want to use some sort of content delivery network?
So you can, so when I say no foreign resources, I mean you can't have an image tag, say source equals like example.com/whatever. You can from XHR cross origin, but it forces you to handle errors gracefully. In the offline case. So you can still get those resources, you just have to do a little bit more work in order to fetch them and stuff them into an image yourself. So you can still have like image source equals data or source equals a blob URL and just XHR the images down. And there are libraries to help make that a little bit easier.
So I've experienced a little bit of app development on PhoneGap and jQuery and such. And one of the issues that I've experienced with those platforms is a bit of sort of UI lag, and it doesn't have that hardware acceleration that a native app would have. So is Chrome apps doing anything to address that?
So unfortunately on iOS there's basically nothing we can do because we're limited to using the WebKit engine that comes with iOS. So there's nothing we can do on iOS. As Hans shot up at that. On Android, we're working really hard to make sure that Chrome runs at 60 frames a second everywhere for all things, which means an awful lot of work to make the compositor and the hardware acceleration really, really fast. And there's no reason that you shouldn't be able to write apps that run at 60 hertz using HTML technology. Web browsers aren't there yet. There's nothing technically, it means we can't do it. It's just a lot of work. So we're getting there. And things are actually, if you saw the Facebook app that Senchar wrote, it's an HTML implementation of the Facebook app, and it's super, super fast. Check it out. Fastbook is, if you just Google for it, you'll see. So things have been worse, they're getting better.
I'm totally going to be fast right now. So I think it's great that all these players are collaborating on the system APIs to get that standardized. Is that also happening with the packaging format?
Yes, so that's part of the execution model drafts that are being sort of hashed out at the moment. There are people talking about like what manifest keys and the form of the what the form of the file should be. So that's definitely going to be part of the spec. Yes.
So does that mean you'd expect to be able to download an application from the Chrome store, run it on Firefox OS, or download an app from the Firefox Marketplace, run it on Chrome as an app as well?
That's the idea. Yeah.
Just in regards to performance and jQuery, I don't know whether they've changed it now, but I know that a lot of the performance reasons with jQuery were because it wasn't using hardware-accelerated APIs, which have existed for a really long time. So you can make it much quicker than jQuery will by default allow you to do, but at the moment it sucks. And this kind of leads into a question that I was going to ask in the browser panel, is that how much of the responsibility to write performant apps lies with the developer, and how much of that responsibility lies with the browser manufacturer, and kind of at what point would you meet in the middle? Like, this is definitely an API problem. They've used the wrong API.
Yeah.
But
so I think we're both responsible. I think the browser developers are responsible to make it possible to write these apps, not just possible, but easy to write these apps. And currently, a lot of the things that a lot of the hoops that you have to jump through to write performant apps are a little bit obscure. Things like when you animate, don't use left, top, and position absolute. Use WebKit transform or Moz transform instead. Those things aren't really necessarily widely known, and they're a little bit counterintuitive. So on the browser developer side, we should do our best to make it easy and obvious how to write performant. And on the app developer side, it's an app developer's responsibility to test and improve their own apps. We can't make everything just work magically, despite my wizard's hat and
The one down the front.
Is there still someone?
Men with black t-shirt right down the front with his hand up.
Sorry.
Thank you. You mentioned early in the talk that one of the purposes of these developments was to make the applications function as though they were native, except obviously that they're written in HTML, CSS and JavaScript, and they run on whatever the operating system happens to be. And I was wondering how these applications then are integrated into the operating system and the package manager. So for example, in Linux, you need an executable file somewhere in the path that can be run to invoke the application, and then that can be run from a shell prompt, or it can go into a desktop file that specifies it to the desktop environment that the user happens to be running. And it wasn't clear for me from the talk as to how all of this works, and obviously how it interacts with the package manager of the operating system, which would have to set the appropriate permissions, presumably when it's installing it. So that...
Yeah, so I understand what you're saying. So on Linux specifically, and we do a similar thing on Windows, the way you actually start an app is you run the Chrome executable and you pass it a flag saying which app you want to run. So if you want to build a desktop file for GNOME that will start up an app, you can just run Chrome with a flag. As for like command line access, like being able to run an app directly from the command line without having to remember its long ID, we don't have a good solution.
photo editing?
So we were using web intents for that, but that spec is sort of stalled at the moment, so we're looking for an alternative solution. We're probably going to roll our own in the meantime, while the specs sort of work comes back and changes direction on web intents. And that's probably going to be some form of URL handler, like in like on Android, or a custom solution that will let you say like, hey, someone please look at this editor, and apps will be able to register for that. So in short, it would have been web intents, but web intents isn't ready yet, so it's going to be something else, and it's not implemented yet. But good question, and that's something that's really important. Time.
Last question.
Time. Last question was down here, Dirk. Sorry, I'll talk to you later. This is Dirk. Dirk doesn't want to ask a question anymore?
I get it.
Okay.
Okay, well, thank you. Does that mean
I was just wondering if it's possible to sort of sideload things that aren't in the Chrome Web Store, or if there's any sort of future plans for that kind of thing.
You can already do that today. There's an API that lets you specify an app ID, and it will install it from the store. Your app still has to be in the store, but the user doesn't have to visit the store to install the app. You can provide your own install button on your website.
But there's no way for you to distribute something without putting it through the Chrome store?
Not currently, but we do. We are thinking about that. Yes.
Yeah, that's about all.
Thank you. Thank you for listening.
Time for now.